Okay, so we are going to start another example, and maybe the most interesting example application of the correlation and covariance is to financial portfolio theory, right? This is really interesting, and there is an amazing, surprising result, like you're going to see in minutes. Okay, so let's think about a very simple example of financial asset allocation theory. So suppose that there are three types of economic status: boom, normal, recession. And I'll assume that, so say next year it will be boom with 25%, or normal 50%, recession 25%. Okay, and depending on how well the economy is doing, two assets, financial asset A and B, will yield different returns. Say A returns 20 in boom, 8 in normal, and 4 in recession. You may think like this, like 20%, 8%, 4%, right? Or you may think it as like $20 when you invest, like when you buy one stock of A, for example. So anyhow, this is natural. A does very well in boom, and it does not do well in recession, which is natural. But there is a very strange financial asset, B, which does better in the recession, right? So in boom, it does not do well, like only 6% return. Normal 10, recession 14. So B is countercyclical, right? Countercyclical. So when the economy goes up, B goes down, right? So it is very special and strange asset. And another thing here is B is relatively safer, right? The difference is, so the lowest is 6 and highest is 14. So floor and ceiling is closer to each other, but A is more volatile, right? So high is higher, low is lower, okay? So we are going to that is just a simple situation, explanation of what we are doing. And what we are going to do is, we are going to calculate first their covariance. So this is slightly different from what we have done earlier, because earlier we started from raw data. When you have raw data, it is calculating sample average, but now you have probability. So when you have probability, you are calculating sum of cross products of deviations weighted by the probability. Okay, let me explain. So idea is same as when you calculate the expectation of variance. Say A has 3 possible outcomes, B has 3 possible outcomes, right? And we know, like from here, you first have to calculate their expectations using the probability. And I intentionally made them 10. Simply there are 10. So take the deviation of A here. So 20 is $10 above 10, 8 is -2, 4 is -6. Likewise, B has its own deviation, right? So 6 is 4 below 10, 14 is 4 above 10. And then we are going to multiply those deviations. 10 times -4, and -2 times 10, and -6 times 4. And at the same time, we will weight. So before calculating average of these products, we also weight them by the probability. So in the end, we are going to multiply probability and deviations, right? 0.25 probability times deviation A, deviation B. So it will be -10. Probability, deviation A, deviation B. Probability, deviation A, deviation B. So now you are going to get some probability weighted deviation producted multiplied. So and sum these three numbers, you are going to get the covariance. Covariance is -16, which is natural because it's minus, because when A does well, does better, B does bad, and the other vice versa. So when A goes up, B goes down, and vice versa. So they are moving in the opposite direction. So the covariance must be minus, right? And 16 doesn't mean anything at the moment. Okay, so we only interpret the sign, which is minus. Now, what we are going to do here is, in this example, in this simple example, the expected return from A and B are the same. Then the investor wants to minimize the risk, the variance or the standard deviation, right? In finance, usually the risk is measured by standard deviation. So in that sense, negatively correlated assets are really valuable, really useful, right? So because when A does better, like B will go down. So that means A will compensate the loss from B. So in the end, they will balance and toward the middle, and vice versa. When A does poor, B will compensate for that. So they are very nice pair if you can combine them to minimize the risk, right? So so we will consider a new portfolio. So now I will buy one stock of A and another stock of B. So I invest on both stocks. That is what I have in mind. And then as a portfolio, because you buy one from one A, one B, so your total return is sum of them. So the dividend from A is $20, dividend from B is $6, so total is 26, right? So when the economy is normal, so 18, in recession, 18. This is new portfolio, and probabilities are like these, okay? So probabilities are the same, but now the portfolio returns are the sum of A and B. Now what I'm going to do here is I will ask you to calculate the variance. Because we are interested in the risk. The expected return is already fixed, 10, right, for both assets. So we would like to study the variance. So without calculating, I believe you know how to calculate that, but without algebra, just guess what would be the variance of A plus B. So as a reference, the variance of A is 36 and variance of B is 8. So A is risky, and you are combining them. You are investing on both. Then what would be the total variance? Smaller or larger or sum or something else? Think about that. Right? The answer is 12. Right? So when you invest on both, the expected return is 20 because $10, $10, so it should be 20. So from there, calculate the deviation and square deviation and weight by the probability and sum. That's how we calculate the variance. It is 12. This is surprising because so you are investing A, and on top of that you also invest on B. Then risk is reduced from A. So when you buy just one stock of A, your risk is 36. But now, because you buy another one, buying another one will reduce the original variance even further below, right? So it's 12. This is diversification, right? So they complement each other, right? They help each other. So it is how you minimize the risk. Isn't it interesting? So we are going to analyze this statistically. So suppose that you have a portfolio X return as A plus B. So this is not exactly linear transformation. It is not one-to-one transformation. It is adding two random variables. You are transforming two random variables into one. So it does not fall into the category of the linear transformation we considered earlier. It's slightly different, mathematically different. So anyhow, we will study the properties. So summation will, like in the expectation, will preserve the summation. So because x equals a plus b, expected value of x equals expected value of a plus expected value of b. Right? This is natural. Right? Expectation is always nice. It's well behaved. But the problem is in variance. In variance, the variance of a plus b is variance of a plus variance of b plus something else. So it is not as clean as mean. So the formula has something additional, but you may think it as this formula. When you expand quadratic form like this, a plus b squared is not just a squared plus b squared. Variance is like square, right? You remember, variance is square. So there should be another term which is coming from cross product, a times b, right? So that corresponds to covariance, right? So this is variance of x, this is variance of a, this is variance of b, and then plus covariance. And then of course, standard deviation goes like this. When you take square root of the variance, you get standard deviation. So, by the way, earlier I explained as if the absolute value of covariance doesn't mean anything. That is true. Practically, the absolute value of covariance means nothing, but mathematically, it is important because it is involved here. You have to adjust this much to calculate the variance of x. So it is needed to calculate the variance of x. So mathematically useful. Okay. So then back to our example. Mean is the same. Mean doesn't matter at all. So variance of A and variance of B are given as 36 and 8. And covariance is minus 16. Then think about this. Variance of x is variance of A plus B and then 2 times covariance. So 36 plus 8 minus 2 times 16. So 36, 8, 44 minus 36 will be 12. That is how we get the covariance of the portfolio. Okay? So as you can see, the minus 16 does huge work here. So the total variance, if the covariance was 0, the variance would be 44. But 36 is reduced by the covariance. So the diversification is coming from the covariance, which is a big deal, as you can see here. Okay. Okay, let's study this a little more. So let's think about when there is no risk diversification. Now we are going to think about standard deviation. That is more standard. So no diversification means the standard deviation of x equals sum of two standard deviations. Then we will let's assume this happens. When does it happen? That's our question. So if this is true, if square both sides, variance of x can be written in this way, right? So expand it, then you are going to get variance of a plus variance of b plus 2 times something, right? Cross product term. And this is what we get from our condition, our assumption. And compare this to the formula. Previous formula, then everything is the same, but this part is the difference. So comparing the assumption to the formula, the covariance must be the same as standard deviation times standard deviation. In this case, so this is when this holds. So this assumption implies covariance equals standard deviation A times standard deviation B. So then, when does it happen? That happens when correlation is 1, right? So remember, so when they are the same thing, move the right hand side to the denominator of the left hand side. Then it becomes correlation coefficient. So it becomes 1. That means when you see no risk diversification, that means A and B are perfectly correlated. That's the only case where you don't enjoy any diversification. In other words, whenever two assets are not perfectly correlated, you will have some kind of risk diversification. So this is the basis of investment. Diversify. It always helps. Theoretically, mathematically, always helps as long as two assets are not perfectly correlated. Of course, in the world, there is no assets that are perfectly the same. So this is always true. And then now let's think about the other case. What happens if two assets are perfectly negatively correlated? We start from here, right? Under this assumption, we start from here. That means covariance is minus standard deviations. And then plug that into our formula, covariance formula. Plug that in here. Then you may rewrite this guy in this way, right? This is exactly a minus b squared, expansion of a minus b squared. So that means your portfolio standard deviation will be standard deviation a minus standard deviation b. So when you have only a, your risk is standard deviation of a, but additionally buying b will reduce exactly as much as the risk in b, right? That is the maximum risk diversification. So the risk in b will offset the risk in a, perfectly offset the risk. That is the other extreme, okay? One more case. What happens if the correlation is 0? So when two assets are independent, they have no effect on each other. So they don't move together, right? They move wherever they want. So their correlation or covariance will be 0. They are not correlated at all. Still, then this assumption, under this assumption, plug that into our formula, variance formula, covariance will become 0. So you only have this much. That is smaller than this guy, expansion of standard deviation of A, standard deviation B. That means the composite standard deviation is smaller than sum of two standard deviations. That means even if two assets are uncorrelated, still they help. Diversification helps. So as you just saw, diversification helps. It is not just coming from negative covariance. Negative covariance will help you a lot more, but even if the covariance is 0 or positive, still financial diversification will reduce your risk. That is a surprising result, possibly like different from, could be counterintuitive. How can positively correlated assets are diversification? Yes, they are, right? As you see. Okay, so this is it for this video. I call it a video. And the last video, the next one is the last one. So we will delve a little more into this theory, portfolio theory. So it'll be more surprising and more interesting. Okay, thank you for watching. See you later.